Swayam Prabha. Digital India. Educated India.
Next big innovation labs are operating in the field of bioprinting and have been building high-performance bioprinters that empowers researchers to achieve path-breaking results in research and clinical applications. Let's know all about it.
I'm Piyush. I'm one of the co-founders of Next Big Innovation Labs and the CEO of the company as well. We've been operating in the space of bioprinting for the past 8 years. In fact, this month, May 2024, we completed close to around 8 years in the space of bioprinting. And we don't only build these amazing machines, but we also look at working at collaborations with multiple government as well as private institutes in the domain of bioprinting to look at how one day we can bridge the gap between transplantable organ demand and availability.
Next Big Innovation Labs was started 8 years back. We were founded in May of 2016. And so when we primarily started, we were exploring 3D printing in healthcare, where we started talking to a lot of doctors, and we're looking at how 3D printed models can serve as guides to doctors. And since our interaction continued with them, they also requested for some sort of implants at that point, which are bioresorbable and that can go into the body without having any side effects. So this got us thinking, and since we have a combined expertise in the engineering as well as biotechnology, that is when we decided to foray into 3D bioprinting, which is a niche technology where it can be used to disrupt the healthcare sector, in the sense that you can use 3D bioprinting as a technology to print organs and tissues within the lab, which can one day be used for transplantation. So currently at this stage, we have developed our 3D bioprinters, which are called Trivima. So since we are a Make in India company, we wanted the technology also to reflect our roots, and we have named our bioprinters Trivima, which means 3-dimensional in Sanskrit. So having the expertise of various engineers in-house, we have mechanical engineers, electrical, embedded engineers, so they have all come together to build this robust platform that we have today currently. So our bioprinting technology, we have installed our bioprinters across 25 plus locations in India, and so we are also looking at international sales currently this year through our partners High Media. And they have been used for a wide array of applications, all the way from developing models, tissue models, which can serve as an alternative to animal testing, up to the stage where researchers are also looking to develop tissues and certain mini organs, if you were to call it, that can go as a transplantation. So this is where researchers are looking at collaborative mode, where they are looking at collaborating with hospitals to do this kind of research, where they can translate the 3D bioprinted tissues into the clinics.
So I think one of the main things that stood out to us, all three of us as co-founders, was when you're looking at the transplantation space, right? You're looking at a big gap between patients requiring organs and the availability of organs, be it the heart, be it something as regenerative as the liver as well. And what we noticed was to achieve that, you required a certain level of engineering for us in order to achieve that. And that's when, we started speaking to a lot of domain experts in the field of bioprinting. When we started speaking with them, one of the major feedbacks that we got was that have control over your own engineering. Like have your own engineering ecosystem and build around it. And that's what led us to actually, build our bioprinters and build the entire ecosystem around it. That's where all of this started. And this was the glaring problem statement. If we want to reach that goal of one day building transplantable organs within a lab, it can be something as simple as a corneal tissue as well, or it can be something as complex as a liver construct. But for us to do that, we needed to have control over the engineering, and that is what we as a company are working towards and have been working towards since our inception. So when you're looking at the body, right, the human body, our organs are in a three-dimensional space, and they're very complex. They're highly complex. They're not simple. Even something that we might think, as human skin, is not that simple. It's very complex, and that is where bioprinting comes into the fore. You're able to print or build something in a three-dimensional space. In 3D printers, most of you would have seen 3D printers, in the space where you're building with plastics or you're building with resins. Here you're printing with hydrogels, you're printing with cells, you're printing living constructs that can one day become tissues or even organs at a later stage. I'm not saying organs is 1 year away or 2 years away. It will take us 8 to 10 years for us to reach that. But the Indian space program also wasn't born overnight. It took decades of research for us to actually get there, and that's what we are doing. This is our step, in moving in that direction. That's what we are working towards when we're building these machines, or when we are customizing these machines for different people. So what you see behind me is actually a 3D bioprinter. So the goal of the bioprinter is to see how we can print even close to around 0.5 nanoliter droplets or 0.5 nanoliter structures. And that's the goal of this entire machine, to get as precise as you can, as precise as the organs in our body is made. So that's how we are building the solution around.
We have 3 patents that are already active in India, and as we innovate, so our name stands for innovation. So we are continuously looking at that route where we can push those boundaries and look at more innovative fronts and technologies. We're looking to file many more such applications, and we're also looking to take these patents internationally as well. So that is where we stand, where we always look at pushing the boundaries of bioprinting and how we can innovate and develop newer forms of technology that can help us get closer to the clinical translation aspect.
I think humanity at large, so we look at it in 3 different ways. One, how is it impacting the planet? The way we see this technology impacting the planet is by reducing the use of animal testing. So bioprinted models, so till now people were using animals for testing, right? But now countries as well as companies are moving away from this, which is a good thing. We are reducing our dependency while developing cosmetic products, chemical products, agrochemical products on animals. And bioprinters like these allow you to build these 3-dimensional structures that can actually be utilized for building those complex structures that can be used for testing these products. So that is one way in which we are sort of getting to a point where we are replacing the animals. That's one thing we believe is good for the planet. The second way in which we believe it's good for the planet is clean meat, where we believe printers like this can be used for printing alternative chicken, alternative mutton that can actually be used for consumption. So that is one application. And third and finally, which I've spoken about before, is how we are building tissues. It can be smaller tissues, it can be complex constructs that can actually go into patients. It can save a person's life. Somebody who doesn't have to go away early has an opportunity to live a little bit longer. So I think the purpose of medicine, or the purpose of our entire healthcare system, is to improve the longevity of human beings, and that's what we've been trying to do. The average lifespan of a human being has been growing decade on decade, improving decade on decade. And I think 100 years back, people would easily pass away at the age of 50. But now with vaccines, with a lot of antibiotics, people are living longer. I think this is the next big step in that direction. We are trying to actually build that entire construct that can actually go in, or that ecosystem that can allow for something like this to happen. So this is one step in that direction. This is how we feel that this can have a huge social impact. I think in total, when we are looking at the space of bioprinting, right, we are looking at how we can create these smaller tissues or smaller organs that can go in for transplantation. And for us to achieve that, I think it requires centers like AIC Jyoti Institute of Technology, where we are doing most of the work that we are doing right now, and also the Atal Innovation Mission that has empowered and enabled companies like us. Last year, in fact, we got the opportunity to speak with the Prime Minister, Mr. Modi, and we got to explain to him about the technology. And in fact, he asked us a very interesting question: what are the applications of such a technology for treating anemia? Which is very different. It's an application we didn't think about, but we believe that there are applications in other rare diseases as well. So this is where the applications of the technologies are. So we've done 25 plus installations across the country, with our first installation happening at the end of May now in Korea. And most of our installations are in government institutes as well as private institutes. We have an exclusive partner, High Media Laboratories, who have been doing a lot, who are distributing our printers across the country as well as across the globe. And the focus for us is to see how we can not only provide these bioprinters, but look at how these bioprinters can be utilized within these colleges for a diverse array of applications. So generally people write a project grant for one application, but when we build the printer, we talk to the customer, we customize these machines based on the requirements of the user, and based on that we sort of build out the entire ecosystem for them, so that once the project is done, there are applications beyond that. Another way that we do is we collaborate with these institutes where we work with them on specific projects. Just to give you a few examples of where our printers are being used, at IIT Hyderabad, it's being used for testing different kinds of biomaterials. If we are looking at Manipal University, they are looking at bone-based applications, especially cartilage-based applications. If you're looking at AIIMS New Delhi, they're looking at developing new biomaterials there as well. So there are a lot of applications where you're looking at direct translation into the clinics as well. So this is where the entire technology is coming together. This is how we as a company are working in that direction.